Okay, class, today we're going to talk about exponent rules. Okay, now we had a lesson over this last week, so this is the video that can help prepare you for the test and prepare you to do the assignment if you happen to miss it. Okay, we had 8 rules basically. Rule number 1 says a to the nth. This is our very basic rule, and it basically means that we're going to do a times itself n number of times. So when we had problems like this right here, we had 5 to the 3rd power. Okay, and we have 2 things that we can do with 5 to the 3rd power. One is write out the factors. And the factors of 5 to the 3rd power, when I say write the factors, that means what does 5 to the 3rd power really mean? And it means 5 times 5 times 5. Okay? Now, we can also figure out what the answer is going to be. And if I ask you to evaluate that, that means actually come up with an answer. So we actually do 5 times 5 times 5 on the calculator, or we do 5 to the 3rd power using our exponent key. Okay? And 5 to the 3rd power would give you 125. Now 4 to the 6th power, if we look at the factors of it, that means 4 times 4 times 4 times 4 times 4 times 4. And if I asked you to evaluate that, you would do 4 times 4 times 4 all the way across, or you would do 4 to the 6th power, and you would end up with 4,096 as your answer. Okay? So this is our basic exponent rule, and we build off of that. Okay? So the next rule, rule number 2, says we're going to do a to the 0th power. Well, what that means is that anything to the 0th power is equal to, and if you type this into the calculator, you find out that it's equal to 1. So anything to the 0th power is going to be equal to 1. So if you do 3 to the 0th power, that's equal to 1. If you do 529 to the 0th power, that will also be equal to 1. Okay? Rule number 3, a to the 1st power. So anything to the 1st power will give you itself. Anything to the 1st power gives you itself, okay? So if we type in 6 to the 1st power into the calculator, we get 6 as an answer. If we do 8 to the 1st power, my 6 to the 1st power again is just 6, and 8 to the 1st power is 8. Sorry about that. Sometimes, you know, the pen just does crazy things working on this little board that I have. Okay? Now we've got rule number 4. Okay, rule number 4, this one is the most complicated out of all of the rules. Okay, and this one we've got this a to the negative n, or 1 over a to the negative n. Now this is our reciprocal feature, because we know that a to the negative n is going to be equal to 1 over a to the nth power. Or if we do 1 over a to the negative n, it's going to be equal to just a to the positive n. Okay? So this negative flips things. Okay? So if I've got this 2 to the negative 4th, what I'm really going to do then is I'm going to flip this. Okay? Because that negative tells me it's going to flip, and it's going to be 1 over 2 to the 4th power. Now if I want to evaluate this, then I will then type in 2 to the 4th power into the calculator, and you end up with 16. So this becomes 1 over 16. So if you were to type in 2 to the negative 4th to the calculator, you're going to get a decimal answer. And that's what this fraction shows. But you're not going to be allowed to give me decimal answers. You must give it to me as a fraction. Okay, so in this one right here, then we've got 5 to the negative 3rd. That's going to be the same as 1 over 5 to the positive 3. Okay, so then that would give me 1 over 125, because 5 to the 3rd power is 125. Now, if the negative exponent is in the denominator of the fraction, it's going to flip it to the numerator. So this would then become 6 to the 4th power over 1, which we know is just 6 to the 4th power. So then, in order to evaluate that, you type in 6 to the 4th power to your calculator, and you get 1296. Okay, so if you were to type this 1 over 6 to the negative 4th, you'll just get a plain regular answer, just a whole number as an answer. Same thing on this last one down here. We've got 1 over 3 to the negative 8, so that's going to be the same thing as 3 to the positive 8 over 1, or just 3 to the 8th power. And we type that into the calculator, and you end up with 6,561. Okay, so anytime you have the negative exponent, it's going to be the reciprocal function. So it's going to flip things. So if it's in the numerator, it's going to flip it to the denominator. If it's in the denominator, it's going to flip it to the numerator. And that's the toughest rule to remember how to do. Okay? The rest of these, you could fake your way out of it, but these you can't. Okay, rule number 5. Rule number 5 says we're going to multiply two exponent expressions together where my base is the same and our exponent is different. So what we do in a problem like this is we keep our bases, we keep our base, and we add our exponents together. So m and n, we just add them together. So that's what it would look like. So if we have this problem right here, what we're going to do is 2 to the third times 2 to the fourth is 2 to the, and then we're going to do 3 plus 4, which gives us 2 to the 7th. So basically what this says is I've got 3 2's. I'm going to multiply them together. And then I'm going to multiply that together with 4 more 2's. Okay, so we end up with 7 2's there all together, so that gives me 2 to the 7th power. Okay? So for this one right here then, we'll keep our base and we add our exponents. 2 and 6 make 8. Now if I wanted to evaluate those, we would then type those into the calculator to get the answer. Okay. Rule number 6. This one's just the opposite of rule number 5. Rule number 5 was I'm multiplying the two exponent expressions together. Rule number 6 is I'm dividing the exponent expressions. Okay, so if we're going to divide the exponent expressions, we're going to keep the base, but we're going to subtract our exponents. Like when we were multiplying, we added our exponents. Well, with division, we're going to subtract the exponents. So in this one right here, we've got 2 to the 4th divided by 2 to the 3rd. So we will keep our base, and we will subtract the exponents, so we end up with 2 to the 1st power. So what this one really means is we've got 2 times 2 times 2 times 2 in the numerator. We're dividing that by 3 2's in the denominator. So we know that in a fraction, if I have a 2 on the top and a 2 on the bottom, they divide out and become 1's. 1's are left behind. So if we do that each time, I apologize for that. Again, this pen is not doing right. So those divide out, we're left with 1's behind. These two divide out, and we're left with 1's behind. And all we're left with is that single 2 in the numerator. Now, if this ended up being a negative number, then we would end up with 2's in the denominator as opposed to in the numerator. Okay, so this one right here, we're going to keep the base. And again, we're going to subtract our exponents, and we end up with 3 to the 3rd power. All right? Now, if this one were, let's say this were reversed. Again, I apologize for that. Let's say that this one here were reversed, and it were 3 to the 4th power divided by 3 to the 7th power. Well, when we do that, we end up with 3 to the 4 minus 7, which gives us 3 to the negative 3rd power. Well, we learned in rule number 4 that the negative is going to flip the expression. So this becomes 1 over 3 to the 3rd power. And that's where we would evaluate it. We would evaluate 3 to the 3rd in the denominator. Okay, because you're not allowed to leave a negative exponent, okay, in the problem. Okay, rule number 7. Okay, rule number 7 is doing an exponent to an exponent. Okay, well, our rule here is we're going to keep our base, but we're going to multiply the exponents together. So this becomes a to the m times n. So in this particular example, we're going to keep our base, but we're going to multiply our exponents together. 5 times 2 gives us 10. Because what this really says is I need 2 of whatever's on the inside. So if that means I need 2 of whatever's on the inside, that means I've got 3 to the 5th times 3 to the 5th. And if we go back to rule number 6, okay, rule number 5 shows that if our bases are alike, we add our exponents together. So, in essence, the quick way of doing it is just multiply these two together. So if we do that in the second example, we keep our base, we multiply our exponents together. 4 times 3 is 12. And then in our last rule that we have, this one you'll notice that, okay, our exponents are alike, but our bases are different. So what we're going to do in this problem is we're going to do a times b, and then we're going to raise that to the exponent level. Okay? So the reason why I put these in parentheses is because in order of operations, you would do the exponents first. So if I just did ab to the mth, or to the m, then only the b is done to the mth power. Okay, so in this one right here, what we're going to do then is we're going to take our bases, we'll multiply those together. 3 times 4 is 12, and then we raise that to the second power. And this one we'll do 2 times 5, which is 10, and then we'll raise that to the third power. Now those are all of our exponent rules, so let's go over them one more time real quick. Our basic one, a to the nth, says a times itself n number of times. So we just do 5 to the third power, which means 5 times 5 times 5. If we have a 0 as an exponent, anything to the 0th power is always going to be 1. If we have a first power, anything to the first power is going to be itself. Anything to the first will be itself. And then we start with some of the tougher rules, the big ones. Okay, this one we deal with a negative exponent. The negative exponent is our reciprocal function. So if the negative exponent is in the numerator, it's going to flip the exponent expression to the denominator, and then that's where we evaluate it. Right? If it's in the denominator, then it's going to flip to the numerator, and then that's where we will evaluate the answer, or the problem. Rule 5 says that if our bases are alike and our exponents are different, we keep our base and we add our exponents. So 2 to the third times 2 to the fourth becomes 2 to the 7th power. If we're dividing, we subtract our exponents. Okay, so this one right here again was keep our base and we subtract our exponents, 4 minus 3 to give us just 2 to the first power. Right? If it ends up being a negative exponent here, like in this example, then you have to flip this to make this your final answer. Right? If we have an exponent raised to an exponent, we're going to keep our base and multiply our exponents together. And lastly, if our exponents are alike but our bases are different, we're going to multiply our bases together and raise that answer to that particular exponent. So those are the 8 exponent rules that I need you to know.